Hello students, today we are going to discuss drawing. It is defined as the removal of a small amount of water or other liquid from a material by the application of heat. It also includes removal of volatile liquids or water from another liquid or gas or a suspension. Drawing is possible when the environment is unsaturated with the water vapor, hence humidity is an important determinant for drying of solids. Drying process is carried out with the help of equipment called dryer. There are several types of dryers based on different mechanisms. Freeze drying keeps biological properties of the proteins and retains vitamin and bioactive compounds in its original form. Pressure can be reduced by a high vacuum pump. At freeze drying, atmospheric pressure is possible in dried air. If using a vacuum pump, the vapor produced by the sublimation is removed from the system by converting it into ice in a condenser. It operates at very low temperature. It is done outside the freezing chamber. Supercritical drying. It involves steam drying of products containing water. This process is feasible because water in the product is boiled off and joined with the drying medium, increasing its flow. It is usually employed in the closed circuit and allows a proportion of latent heat to be recovered by the recompression, a feature which is not possible with the conventional air drying. So, in freeze drying process, the latent heat of drying is used for the drying the product. The process has potential for use in foods. It carried out at reduced pressure to lower the boiling point. Natural air drying take place when the material are dried with unheated forced air, taking advantage of its natural drying potential. The process is slow and weather dependent. So, a wise strategy fan must be devised considering the following condition. The following factors to be considered in case of fluidized bed dryer: air temperature, relative humidity, moist content, temperature of the material being dried. Grains are increasingly dried with the techniques, and the total time including fan off and on periods may last from 1 week to various months. It is a very lengthy process if a winter rest can be tolerated in the cold areas. The application of freeze drying include: this drying can be used in preparation of bulk drug like dried aluminum hydroxide, spray dried lactose, powdered extracts. The preservation of food products, freeze drying is very common in case of food product. Drying is necessary to avoid deterioration. Example: crude drugs of animals and vegetable origin, synthetic and semi-synthetic drugs, aspirin, penicillin tablets undergo chemical decomposition process. Blood product, skin, tissues undergo microbial decomposition can be dried using freeze drying process. The improved characteristics of the drying products which can be obtained by the freeze dry process. It produces the material with spherical shapes, uniform size, free flowing, enhanced solubility. Granules are dried to improve the fluidity and compression. Improved handling can be done. Removal of moisture makes the material light in weight and reduce the bulk of the material, thus reduce the cost of the transportation. The storage, efficient storage of the material, stability enhancement by the removal of the moisture significantly reduce the rate of chemical reaction. The chances of microbial attack or enzymatic action are reduced. So, it improves the stability. Now, coming to the theory of drying. As all we know that drying is a process of removal of water from the solid surface. In this case, these drying take place in various steps. There are some main points in case of drying. Number one point is bound moisture. It is the minimum amount of water held by the material that exert an equilibrium vapor pressure less than the pure water at the same temperature. The substance containing bound water are often called hygroscopic water. Hygroscopic substance contain quantity of water that is called bound water. Next is the unbound moisture. It is the amount of water held by the material that exert an equilibrium vapor pressure equal to that of the pure water at the same temperature. Unbound water exists mostly in the voids of solids. Measurement of the moisture in a wet solid is referred as moisture content. Moisture content means percentage moisture content equal to weight of water in the sample upon the weight of dry powder multiplied by 100. Now come to the mechanism of drying. How drying take place in any solid materials. So, this drying involve mainly two processes, heat transfer and mass transfer. First one is the heat transfer. Heat transfer take place from heating medium to the solid, except in the dielectric or high frequency electric drying, where heat is generated within the solid and flows to the exterior surface. Mass transfer. Mass transfer involves the movement of the moisture to the surface of the solid from interior or from bulk of the material to the exterior surface of the solid, and then subsequent evaporation from the surface. The transfer of vapors from the surface of the solid to the surrounding area is effected by external condition. There are various factors which can affect the drying of the solid. These factors are temperature of the air, temperature of the environment, humidity of the air, air flow rate, pressure, evaporating surface and surface area of the evaporating surface. What is equilibrium moisture content? Equilibrium moisture content is a very important point in case of any solid material. That is the amount of water that exert a vapor pressure equal to the vapor pressure of the atmospheric surrounding it. Equilibrium moisture content in a wet mass is shown below. Depending upon the temperature and humidity condition, solid may absorb or lose moisture. Listen students, that equilibrium, no material, no solid can be dried by any drying process below its equilibrium moisture content. Equilibrium moisture content product can be dried till equilibrium moisture content can be reached. Now come to the desorption. What is desorption? When air is continuously passed over the solid containing moisture more than the EMC, listen, more than the EMC, then solid loses water continuously till EMC reached. Means when the EMC is reached, drying stops. So, this phenomena is called as desorption. If excess moisture content more than EMC is present in any solid material, then material loses moisture content to reach the EMC, or if less moisture content is present in the material, then material absorb moisture from the atmosphere. So, this process is known as the sorption. When air is continuously passed over the solid containing moisture less than EMC, then solid material absorb water continuously till equilibrium moisture content is reached. This phenomena is known as the sorption. Now, Come to the methods how we can determine the EMC. For this, we take the solid samples. We take the solid sample and we place in a series of the closed chamber, that is desiccator. Each chamber consists of solution which have the specific saturated humidity in the enclosed air space. Solid samples are exposed to the several humidity condition in the desiccator. The exposure is continued until the material attains a constant weight. Initially, before putting the material in the desiccator, first we weigh the material, then we put the solid material in the different humidity chamber for some time. After that, we take out the material from the chamber, then we again weigh the material. The difference between the final weight and initial weight of the material gives the moisture content. There are various factors which can affect the equilibrium moisture content, like nature of the material. If material is porous, if material is hygroscopic, if material is non-hygroscopic, these all affect the EMC. Non-porous insoluble solid have an EMC 0. Non-porous means talc, that have EMC 0. For fibrous or colloidal organic substance, EMC values are high because these are fibrous material. For porous solids, EMC values are very high and valuable. Second factor is nature of air. For air of zero humidity, EMC of all materials is 0. If the humidity of the material which is passing over the material which we have to dry, then EMC is 0. As the temperature of the air increases, the EMC of the solid decreases. Important parameter is free moisture content. Free moisture content is the amount of water that is free to evaporate from the solid surface. I have already told you that EMC is the amount of moisture content that is to be present in any material. FMC means free moisture content which is free to evaporate from any material. So, FMC is equal to total moisture content minus equilibrium moisture content. The moisture present in the solid can be expressed on a wet weight or dry weight basis. Percentage loss on drying, that is known as LOD, equal to mass of water in sample in kilogram upon total mass of weight sample in kilogram into 100%. Why this we can calculate? Now, we can calculate the moisture content by using this formula: mass of water in the sample upon mass of the dry sample into 100. The rate of drying of a sample can be determined by the suspending the weight of the material on a balance in a drying cabinet and measuring the weight of the sample as is dry as a function of time. Rate of drying or drying rate can be calculated by using this formula: weight of water in sample upon time taken to dry that material into weight of the dry solid. Now, drying take place by different mechanism and in different stages. So, drying rate curve is a curve that is plotted between the amount of water versus the time. In some process having a relatively high initial moisture content, an initial linear reduction of the average product moisture content is a function of time, may be observed for a limited time. It is in drying rate, first phase is drying is completed in different phases. First phase is when we start drying a product. There are several steps in drying that product or reach to the EMC. First stage is constant drying rate period. Usually in this period, it is surface moisture outside individual particle that is being removed. Moisture content is removed from the surface. In drying, the drying rate during this period is mostly dependent on the rate of heat transfer to the material being dried. Therefore, the maximum achievable drying rate is considered to be heat transfer limited. The high will be the heat transfer rate, the high will be the drying rate. If drying is continued, the slope of the curve, the drying rate becomes less steep. Initially, then becomes less steep. Second rate period is falling rate period and eventually tends to nearly horizontal at very long times. The product moisture content is then constant at the equilibrium moisture content, where it is in practice in equilibrium with the dehydrating medium. In the falling rate period, the water migration from the product interior to the surface is mostly by the molecular diffusion. That is, the water flux is proportional to the moisture content gradient. Moisture content gradient means the difference between the moisture content between the two surfaces. This means the water moves from the zone with higher moisture content to the zone with the lower values, from bulk to the exterior surface, a phenomena explained by the second law of thermodynamics. If water removal is considerable, the product usually undergo shrinkage and deformation except in a well designed freeze drying. The drying rate in the falling rate period is controlled by the rate of removal of moisture from the solvent from the interior of the solid being dried and referred to as being mass transfer limited. It is obtained by plotting a graph between free moisture content on the x-axis and drying rate on the y-axis. Depending on a external condition and internal mechanism of fluid flow, solids show different drying patterns. A typical drying cycle of a solid can be divided into three distinct zones. Number 1, initial adjustment period, then constant rate period, then first falling rate period, then second falling rate period. First stage is initial adjustment period. It is a time corresponding to the, this is a curve, drying curve, which is plotted between the equilibrium moisture content versus the time of drying. So, in this graph, the AB line shows or is called as the heating up period. During this period, the solid absorb heat and temperature is increases. Any weighted substance when kept for drying, it absorb heat from surrounding and vaporization of the moisture take place, which cools the surface. Heat flows to the cooled surface at high rates and leads to the rise in the temperature and evaporation again. This continue, and after some time heating and cooling rate become equal. This temperature is equal to the weight bulb temperature of the drying air, and it is referred by the point on the graph. Second period is constant rate period. It is the time corresponding to the BC line in the graph. The temperature remains constant and rate of drying is constant because the heating rate and the cooling rate become equal. There is a continuous liquid film over the surface of the solid. Moisture evaporating from the surface is replaced by the water diffusing from the interior of the solid. Listen, the moisture content is present on the surface as well as in the bulk of the solid material. The moisture diffused from the bulk to the surface, then from surface to the environment. So, also the drying rate remains constant as shows in curve by region BC. So, BC shows the constant rate period. In this period, rate of diffusion equal to the rate of evaporation. The diffusion of the water from the bulk to the and the diffusion of the water vapor from the surface to the environment is equal. As drying proceeds, the coarse capillaries are completely depleted of water and solid falls through the maintained uniform film. The area over which moisture film is not present is known as the dry spots. From the bulk, moisture content diffused to the surface, and from the surface diffused to the environment. So, where the moisture content is less, there are dry spots are formed. Such dry spots start appearing and drying rate start falling. And this is the point C, at which decrease in drying rate start, and it is referred to as the critical moisture content. Now come to the next line of the curve, that is first falling rate period. It is also known as the period of unsaturated surface drying. It is the time correspond to the CD curve, first falling rate period. It is the time corresponding to the CD line of the curve. During this period, surface water is no longer replaced at a rate fast enough to maintain a continuously film on the surface. Dry spots begin to appear and rate of drying begin to fall off. The point is referred to as the second critical point. Point C is the critical moisture content and point D is the second critical point, and in this phase the drying rate is decrease. Last phase is the second falling rate period. It is the time corresponding to the DE in the graph. During this period, the rate of drying falls even more rapidly than the first falling rate period, and no film will be present on the surface. At the end, the drying rate becomes 0 and the moisture content of the solid at this point will reach to the equilibrium moisture content. So, drying rate becomes 0, as I have already told that no solids can be dry less than the equilibrium moisture content. Equilibrium moisture content is defined as the mass of water per unit mass of dry solid when drying limit has been attained by use of air at any given temperature and humidity. Now come to the freeze drying. It is also known as the lyophilization process. System is made solvent loving for removing the same. The principle of freeze drying is, in freeze drying, water is removed from the frozen state by sublimation, that is direct change of water from solid into the vapor without conversion to the liquid phase. Solid liquid vapor equilibrium phase diagram of water is useful to decide the experimental condition. The drying is achieved by subjecting material to temperature and pressure below the triple point temperature of the water. Under this condition, any heat transferred is used as the latent heat and ice sublimates directly into the vapor state. The water vapor is removed from the system by condensation in the cold trap maintained at a temperature lower than the frozen material. The phase diagram for the water system is shown in the corresponding figure. The phase diagram consists of 3 separate phases representing the phases of water solid, liquid vapor. The point O is the only point where all the 3 phases can coexist, and it is known as the triple point. Solid, liquid and gas phase exists at this point. This is known as the triple point of water. Now come to the construction of the freeze dryer. Freeze dryer consists of drying chamber in which trays are locked, heat supply in the form of radiation sources, heating coils, vapor condensation and absorption system, vacuum pump and steam ejector, or both are there. The working of freeze dryer are in the following step. First step is the preparation and pre-treatment. The volume of the solution introduced into the container is limited by its capacity. Therefore, pre-treatment is essential. The solutions are pre-concentrated under the normal vacuum tray drying. This reduces the actual drying by 8 to 10 times. We come to pre-freezing step. Pre-freezing is done to solidify the water in the vials, ampoules or bottles in which the aqueous solution is packed are frozen in the cold cell minus 50 degrees centigrade. The normal cooling rate is about 1 to 3 Kelvin per minute, so that large ice crystals with relatively larger holes are formed on a sublimation of ice. This is also responsible for giving a porous product. Third step, primary drying. It means sublimation of ice under vacuum. The temperature and pressure should be below the triple point of water, that is 0.0098 degrees centigrade and 4.5 pound for sublimation. When water is alone present, when a solution of a solid is dried, the depression of freezing point of water occurs. Hence, it is essential that the temperature be brought below the eutectic point temperature. The pressure and temperature at which the frozen solid vaporize without conversion to the liquids is referred to as the eutectic point. Depending on the drug substance dissolved in the water, the eutectic point is determined. Their usual range is from -10 degree centigrade to 30 degree centigrade. The condition of 1 to 8 Kelvin below eutectic point is sufficient. Vacuum is applied to the tune of about 3 mm Hg on the frozen sample, and the temperature is linearly increased about 30 degree centigrade in a span of 2 hours. Heat is supplied which transfer as latent heat and ice sublimates directly into the vapor stage. So, main principle of freezing drying method, conversion of ice directly into the vapor without conversion into the liquid phase. Primary drying stage removes easily removable water about 98 to 99%. Now come to the next step, secondary drying. It is removal of the main water is removed in the primary drying process. Very less quantity of water, remaining water is removed in the secondary drying process. So, in this the moisture is removed under high vacuum. The temperature of the solid is raised to as 50 to 60 degree centigrade, but the vacuum is lower below that is used in primary drying. So, high efficient vacuum is applied. The rate of drying is very low and it takes about 10 to 20 hours. Next is the packing step. Packing is done after vacuum is replaced by the inert gas, then the bottles and vials are closed. The freeze drying is used for drying of number of products, blood plasma and its fractionated product, bacteria, viral cultures, antibiotics, plants, extract, steroids, vitamin and enzymes. The advantage of freeze drying process is thermolevel substance can be dried, denaturation does not occur because we use the very low temperature, migration of the salt and other solutes does not take place, moisture level can be kept as low as possible, product is porous and uniform, sterility can be maintained, material can be dried in the final container such as single dose or multiple dose vials. The disadvantage of this process is that this product is prone to oxidation due to high porosity and large surface area. Therefore, the product should be packed in vacuum and using inert gas. Equipment and running cost is very high, the period of drying is very high, time cannot be shortened. It is difficult to adopt the method for solution containing non-aqueous solvents. I hope you all will enjoy this topic. For more information regarding this subject, please visit at www.cec.nic.in. Thanks and goodbye.